Alright, so welcome back. Today we'll be doing valid parenthesis, which is an easy question. So it's a pretty simple question to understand. So basically we are given a string S containing just the bracket characters like the square bracket, the curly brackets, and the normal bracket. We want to basically check if the input string is valid. So it's valid if the open brackets are closed by the same types of brackets, open brackets are closed in the correct order, and every closed bracket has a corresponding open bracket of the same type. Right, so I mean, let's just look at the example, then it makes it easier to understand. So we're just basically given like a string, right, and we check if the bracket format is correct. So in this case, like obviously it's correct. Why? Because we have one open normal bracket and is immediately closed by one closed normal bracket. And in this case, it's valid because you see, the moment whenever we open a normal bracket, we are immediately closed by one. When we open a square bracket, it's closed by another square bracket. And lastly, if when I open a curly bracket, it's also immediately closed by a curly bracket. In this case, this will be false because you see that when we open a normal bracket, we can see that the closing bracket is not a corresponding normal bracket. Therefore, this is a invalid bracket string. So I mean, this is what we just gone through, right? And in this case, we can notice that when we have basically what we want to notice is that we can actually open as much brackets as we want. However, the moment, you see, we can open like these three normal brackets and even open a square bracket. However, the moment we encounter a normal closing bracket, the closing bracket must correspond to the latest opening bracket, right? So we can see that as we go through, right, we can see that, look, at this point, the latest opening bracket is a what? Is a normal bracket. But the moment we open a square bracket, now the latest opening bracket is a square bracket. So whenever now we see a closed bracket, right, it has to be a square bracket, meaning the next closing bracket must correspond to the latest open bracket. Yeah, it's quite a tongue twister. So we can see that if we encounter a closing bracket that does not correspond to this square bracket, we can say that immediately this is invalid. So the next one to be valid, it has to be a closing square bracket. So now that we encounter a closing square bracket, we can actually just ignore this, and now we update the latest opening bracket to a normal bracket. So now whenever we encounter a closing bracket, it must be a square bracket. It must be a normal bracket, right? So then we can cancel off and like this. So this will be a valid, right? So how do we actually keep track? The point is to actually keep track of the latest opening bracket, right? So how we can do that is by keeping a stack. So a stack is just honestly just a list, a normal array, right, within normal data structures. So the stack is basically gonna contain, whenever we see an open bracket, we can add it to the stack. Because we can have as many opening brackets as we want, we just want to keep track of the latest opening bracket. It's only when we encounter a closing bracket, then we can start doing the check whether it corresponds to the latest opening bracket, right? So we're gonna start just coding, and then we're gonna see how it works as we code. So we're gonna keep track of a list. So this list is gonna be whatever is the currently open, right? So it may contain like this, something like this, right? So this will correspond to if we added 3 opening brackets at once, right? We add it all to the stack, right? So then we can also keep track of the matching brackets. So the matching bracket is basically just gonna be a dictionary that matches the closing brackets to the opening brackets. So the reason why we want to maintain this dictionary is basically whenever we encounter a closing bracket, right, we actually want to see what's the corresponding opening bracket, and then we check, is the corresponding opening bracket the latest open bracket in current open. If that's the case, then we can just cancel them out, and we know that it's still a valid string, right? So now we gotta do the actual check. So for the character in S, right, we gotta check if the character is in matching. Right, so if it's in matching, this means that the character is a closing bracket, right? Because we can see that the keys are these closing brackets. So if this character is in matching, meaning that the character is one of these 3 characters, so it is a closing bracket. So remember, if it's a closing bracket, what do we want to check? First, we want to check if the length of the current open equals to 0. Because if it's 0, meaning there's no current open bracket. So you're trying to close something that doesn't exist, right? You're trying to close something that is not open at all. So we know that this immediately is false, because we just return false. Next, we're gonna see if matching at the character. So now here is actually checking for the corresponding open bracket. So if this character is this closing bracket, we know that the corresponding open bracket will be the square open bracket. So if the matching character equals to the current open at the negative index 1. So meaning this, we are trying to find the latest one. So this negative 1 basically gets the character at the end of the stack. So if the stack contains like this 3 and this, right? So if you do current open at index negative 1, it will get the latest one. So which is what we're trying to find. We're trying to find if the closing bracket corresponds to the latest open bracket. So if it corresponds, then good. We can just pop it off from the current open. So this pop will basically remove the last element, because we know that it closes it, right? So it neutralizes it. So you can just pop it off at the end. And so now the current open bracket will be this normal bracket, right? So if it doesn't match, so like you see that here, it doesn't match, right? We know that obviously is false, is invalid, right? So we just return false. And then at the end, we want to return whether the current open equals to an empty array. So because we want at the end, we want everything to have closed, right? Whatever's open has been closed. If some has been open but not closed yet, we know that current open will not be empty. And if it's not empty, meaning that it has not been closed, and we can just return false. But if it's empty, that means that all open brackets are closed and the array will be empty, so we can just return. Okay, one more thing we have to add here is that, so we see that here, if character is in matching, meaning this is a closing bracket. However, what happens if it's an open bracket, right? So in this other branch case, we know that the character is an opening bracket. So if it's an opening bracket, we know that we can just add it to the current open dot append character, meaning we can open as many brackets as we want, right? So we just keep adding it to the end of the list, right? So we just open it, and then at the end we just run it, and you can see that it passes, beats 88.77%. So I mean, it also runs in O of n solution, of course, because we're just basically looping each character and just keeping a stack, right? Yeah. So I hope this helped you. Thank you for watching.